Okay, so we're trying to get a good feel for some of the properties of an exponential. So what I ask you to do is construct the exponential shape in a rectangle dimensions 200 by 800 and so forth. Now, that's an instruction I can give students who are in my free calculus class, but not everybody in this class would be in my free calculus. So let's just see what that graph looks like. Okay, if you do the graph according to the instructions, you get a rectangle and it goes from x equals 0 to x equals 800 and y goes from 0 to 200. So that the x and y axes now another thing about it is we get these vertical lines. This line, well, these vertical lines are equally spaced 0 to 800. So there are 4 spaces here, 1, 2, 3, 4. Each of them must be 200. So I'm going to label up here. Okay, this line is x equals 200. This is x equals 400. This line here is x equals 600. And this line is x equals 800. So x is 200, 400, 600, and 800. And you can read that right off by looking at the equations of those lines. Also, this line is halfway from the top to the bottom. So halfway from 200 down to 0 is 100. So y equals 100 here. And then this line is halfway from here to here. This line is halfway between the line before and the lower edge. So that's halfway between 100 and 0, which is 50. This is halfway between 50 and 0, which is 25. Then this last one, I really isn't room to label it over there, so I'll label it over here. That's y equals 5. And I've actually got it a little bit too low. Get the idea. Okay. Now, what I ask everybody to do is estimate y when x equals 500 and when x equals 700. Okay. Now this line is a little bit too far to the left, so I'm going to kind of fudge a little bit. I'm never going to fudge. A little further to the right. Okay. Now I'm going to locate x equals 500. Where's x equals 500? Well, here's x equals 400. Here's x equals 600. X equals 500. It's going to be right halfway between these. So that's not very accurate. There's some inaccuracies on my picture. That's okay. There are always inaccuracies on your picture. If x equals 500, what's y? Well, right here's where the x equals 500 line meets the graph of this curve. So right here is a horizontal line. And what's the y coordinate of this line? Well, looks like it's between 50 and 100, somewhat closer to 100. So I'm going to say that's about y equals 70, which corresponds to the estimates of people in the class made. Just make sure I'm recording. Okay. And then where's x equals 550? So that was supposed to be x equals 500, x equals 700. X equals 700 would be halfway between 600 and 800. So I'm going to say this line here is x equals 700. And now we've got a point on the line here. And if we do horizontal line through that point, it looks like it were between 100 and 200. And it looks like over here, it looks like we're about halfway. The line kind of slowed down a little bit there. It looks more like we're a little less than halfway. But I'm just going to kind of try to compensate for some of that. Say y equals 145. Halfway here, it's a little below halfway here. I'm estimating 145. Okay. Then I ask for the ratio. So again, if you're, viewing this as a distance student, you would stop now and find that ratio before I tell you. Already done that in the class. Okay, but so I can say between x equals 500 and x equals 700, according to our graph, y appears to change from 70 to 145. So I say it changes from 70 to 145 approximately. The ratio of y values is what? It's 145 over 70, which is approximately 2.07. Okay. Then I asked to make estimates for x equals 350 and 550. And if you haven't made those estimates, you make a copy of my graph and make your estimates. Well, the estimates that I get, incidentally, in class we had estimates of 75 and 150 or 140 and 70. And all the estimates I saw in class came out exactly 2. Okay. Well, now we estimate between 350 and 550. Okay. 350 is between 200 and 400. 300 would be halfway between, and 350 would be halfway between the halfway and the 400. So that would be about, if x equals 350. We make the mark on the line, and it's just a little bit below the y equals 50 mark. So we're going to make the estimate that y equals approximately equal. I'm going to say 5. Then for x equals 550, well, 550 is between the x equals 400 and the x equals 600 line. It's 200 units to the right of 350. And remember that these vertical construction lines here are spaced by 200. We conclude that 550 is going to be about here. a little hard to read, but there are two lines for 350 and 550. It appears that the y coordinate, or we cross the graph here. Say y is about 95. Okay. So if to the y ratio, it's the ratio of these, it's 95 over 45, which is approximately equal to 2.1. Okay. Now, in class, one of the estimates we have is like 1.84. So that estimate is somewhat lower than 2. My estimates are somewhat higher than 2. But most of the graphs I see in class are better than mine, because they're made with pen and made a little more carefully than I made mine. I don't want to be too careful because I'd hate to seem like I was showing off. Okay. I want to make them, I don't want the graphs to be too precise because I want you to appreciate the fact that there's some uncertainty when you do things by a graph. And of course, we've established that pretty well. And this course and in my pre-calculus. And the purpose of this course is to just get good at seeing what the graphs tell us. Now let's make an observation here. Okay. The way this graph is constructed, every time you move over 200, you double the y coordinate. Okay. The x and y coordinates, if you put the points on the graph, and 8. Now those are the coordinates of the points I've marked with x's here, or the vertical lines across the horizontal construction lines. The first point isn't on the y equals 0 line. It's not on the y-axis. It's not on the lower edge of our rectangle. It's on the first construction line above the lower edge. There are 1, 2, what's the third one? I can't find it over here. 3, 4, 5 construction lines, each twice as close to the y-axis as the one before. So that at 800, where y equals 200, at 600, we're twice as close to 0. Well, that puts us at 100 because halfway between 200 and 0 is 100. Halfway between this line and this line is this line. That's halfway between 100 and 0, which is 50. So halfway between 100 and 0 is 50. Halfway between 50 and 0 is 25. Do I have too many lines there? And for 12.5, it shouldn't even be there. Close line is y equals 25. It should be. Am I going crazy or is it you? It's not you. Maybe it should be. Because we go over 1, up 1, over 1, up 1, over 1, up 1. one. Either, so why is the number not coming out? It's because it's zero. Why is it zero? Why is 12.5? Okay, now that was really kind of bigger. Yeah, I know better. And remember what I said on the left edge of the rectangle, we're not down here at y equals zero, we're down here at y equals 12.5. Now, when I was doing this, I wrote the zero there, so we're gonna go halfway to zero every time. But zero actually never occurs. The y value, as we go twice as close to the x-axis, the y value, well, as we move left one line, if we move left 200 units, the y value is cut in half. So if we moved over one more unit, this graph could be extended to the left. And if we moved over 200 units here, y would become 6.75. Okay. And we keep moving to the left, and y would keep becoming half as great. Pretty soon, y would get really small, but it never reaches the x-axis. And that's one of the properties of the exponential function. So it's up there, putting the zero there without thinking. Okay. Had a reason for doing that. It just wasn't the right thing to do. So there we have table. Now what I'm observing is, look at what happens every time we move 200 units in this table. If we go from 0 to 200, that's the same as moving 200 units in the x direction. What happens to y? It goes from 12.5 to 25. Well, 2 times 12.5 is 25, or 25 divided by 12.5 is 2. We move 200 units here, y doubles again from 25 to 50. If we move 200 units from 400 to 600, y doubles from 50 to 100, 600 to 800, y doubles from 100 to 200. Now, this is kind of a roundabout way of establishing it, but now if you've made these estimates, I find, okay, well, again, notice from 500 to 700 is 200 units. If this pattern of doubling every time you move 200 units in the x direction, if that pattern continues, which it probably ought to if it's going to be consistent with this, y value should double. Okay, well, between x equals 500 and 700, okay, y changes from 70 to 145, right? By our estimates. Well, if we missed a little bit, if that 70 is a little bit low and that 145 is a little bit high, that this would be exactly twice. It's just a little over twice as big. So that's our ratio. 145 over 70 is our ratio of 145 and 70. That ratio is, by our estimate, is 2.07. By what we expect from the pattern we see here, it should be exactly 2. So we didn't miss 2 by much. Then between x equals 350 and 550, y goes from 45 to 95. Well, if it's 45 to 90, or 47 and a half to 95, it would be exactly double. If I do the ratio, I find the ratio is just a little more than 2. Some people in the class found ratios around 1.8 or 1.9. Oh, the big deal, and this is a big deal, which is why we spent a fair amount of time on it. doubling time. You know, without doing a rigorous definition of that. Yeah, here just by constructing the exponential shape and then slapping the dimension on the rectangle. Get an exponential function. We're gonna see the formula for that function in a minute, but for this function. Doubling time is 200. Every time you move 200 units in this direction, the value doubles. Now the formula for this function. Detail how I get that formula, but it's just basically from the whole idea of transformation. Well, I'm gonna is using 2 as the base for our exponential function. It's y equals a times e to the x. Okay. Y equals 12.5 when x equals 0. So 12.5 equals a times 2 to the 0. Now we're going to stop for a second to solve that equation for a. If you see what's going on there, you're going to find that it's really, really easy to solve for a. But if there's something you don't see, that a lot of people won't see, then you might have trouble solving it. But give it a shot. Okay. The only this is 2 to the 0. Okay, some people wrote 2 without the 0, then they got 8 times 2 equals 12.5, and divided 12.5 by 2 and got 6.75. And that's not right because this isn't 2, it's 2 to the 0. And some people thought 2 to the 0 was 0, despite the fact that we've shown many times that it isn't. Okay. And that's not an unusual mistake. It's one that says terrible things about the way algebra was taught in K through 12. Okay. 2 to 0, any number to the 0 power is 1. So A is 12.5. Okay. Now let's take another value. Okay. What other point might we use on the graph to figure out what the value of hold it. Not a times 2 to the x, it's a times 2 to the kx. Where k is not to be confused with a vertical shift. Okay. Often we'll use a different. I'm gonna use L. I don't like using K because context, or we might well think of K as being a vertical shift. Okay. 2 to the alpha x. Now it's still it's still 0, so it's still 1. We still get this. Okay. So we could pick any point on this graph. Okay? I'm gonna go ahead and pick 100, kind of, okay? If y equals 100, but x equals 400, then x is 400, so you have alpha times 400, which I'll just write as 400 alpha. Okay? Now, hundred by 12.5, you get 32. Okay? Well, if you raise 2 to what power? What power would you raise 2? So what power would you raise 2 in order to get 32? Well, you square 2, you get 4, right? Square 4, you get 8. So you square 2, you get 4. Multiply that by another 2, you get 8. Multiply that by 2 again, you get 16. You multiply it by 2 again, you get 32. The 32 is the power of 2. 2 to the 5th equals 32. Okay? So since 2 to the 400 alpha equals 32, 400 alpha must be, well, hell, you must have got out of bed the wrong way this morning. Equals 5, not 32. 400 alpha equals 5. Okay. So alpha equals you can reduce this fraction to 1 over 80. In decimal form, that's 0.0125. Well, I used up this board, I probably could look at this one another. But we conclude this that our function has an equation that we can pretty easily write. Now I know what alpha is, and we know what A is. It's 12.5 times 2 to the 0.0125x. And all these steps are steps that you can understand. Now, you might not be able to put them all together, and probably wouldn't ask you to put them all together on a test or anything, so okay, or as an optional problem. But let's test it. Take your calculator. Let's just find y when x equals 550. Now remember over here on the graph, we estimated that when x is 550, y is 95, right? See how I did with my estimate. Got your calculator? X equals 550 and see what you get. Okay, now this goes on right along because what we get doesn't work. If y is 100, x equals 400, then if we plug into this with alpha equal, I'm sorry, with a equal 12.5, well, the 400 goes here, and that's right. What goes here? 1 is 100. And when I divide that by that, I get 4, not 8. Okay. I'm sorry, that's 8. 2 to what power equals 8? 2 to the third equals 8. So 400 alpha equals 3. Yeah, that's good. So alpha is 3 over 400. And that doesn't reduce. But that's approximately equal then. Well, that is equal, never mind. That's equal to 0.0075. So instead of 0.0, yeah, 0.125, it's 0.75. Now, if you plug that in, go ahead and see what you get. Okay, did you get a result? Hang on a minute. Okay, unfortunately, due to some errors I've made, and maybe even another one, because I did all that stuff. Yeah. This equals a here. 3 over 400, I think is 0.0075. It would have been safer to use 3 over 400 and do the thing with the fraction rather than the decimal, but I'm pretty sure that's right. 4 over 400 would be 0.01, that'd be 1%. and this is 3/4 of that, it has to be right. Also, I didn't write down X here. Okay. So there's the function. If we evaluate that with X equals 550, we're going to get something close to 95. When we plugged in the calculator, we didn't get it. So we're going to mess with this a little bit when we start the pre-calculus class. And we're just going to start with synopsis here without going into the details. Because what we really want to get the idea of is there is a consistent, a constant dose. And it turns out that if we evaluate this, which will all start at pre-calculus class, we do find that there's a constant dose. Okay. And that's the most important characteristic perhaps of an exponential function.